Hi champ, how are you doing? Welcome into the another amazing session. I'm your master teacher Shivam Gupta. In today's class, we're going to discuss the division algorithm in the polynomial chapter. So let us start, champ. So in this class, we will talk about the division of the polynomials and the division algo, right? After that, we will see the remainder theorem, factor theorem. Very important topics. So let's start the class, champ. So first of all, I believe that you have studied the division of the polynomial already, right? You already know how to divide a polynomial. But for an example, just let me show you. Let's divide this cubic polynomial by this quadratic. So how to do it? Very simple. First of all, it's a x to the power 3. And here I have x to the power 2, right? So I will multiply by x in order to get the x power 3 cancel out. After that, I'm getting here minus 4x square. Again, champ, here it is x square, here it is x square. I don't need any more power of x. But here it is what? Minus 4. Here it is 1x square. So I have multiplied by minus 4. And I got some remainder. So now, champ, let me just make you again go through it, the terminology. Champ, this is known as a divisor, right? By whom which you are dividing. The polynomial which is getting divided is known as the dividend. This is my remainder and this is my quotient, right? And the one very important thing is what? That the degree of divisor is always greater than the degree of remainder. Like degree of remainder is 1, degree of divisor is 2. So degree of divisor is always greater than the degree of remainder. Okay. So now, champ, let's move on to the division algo now. Now, let me make you understand the algo behind it. Champ, when we are dividing the number 15 by number 2, right? So, we are getting quotient 7 and remainder 1, right? It's very easy. So, now this dividend 15 can be written as 2 multiplied 7 plus 1 and which can also be written as dividend equal to divisor into quotient plus remainder. Very easy, right? I hope it is clear. Chaliye, very good. So now, champ, in the same way, we can write in the case of polynomials. Okay. In the case of polynomials, we can use the same relation. That dividend is equal to divisor into quotient plus remainder. So now, champ, let me show you that how it is verified in the case of the question which just we have solved. So, champ, in our question, the dividend was px, right? Divisor was gx, quotient was qx, and remainder was rx. So let's put all these polynomials value in the division algo, right? And let's see how to do it. So, champ, after putting all the polynomials in their respective place, we got what? We get RHS equal to LHS. That means what? This means that dividend is equal to divisor into quotient plus remainder is also applicable in the case of polynomials. I hope it is clear. Very good. Now, champ, let's move on to the remainder theorem, a very important topic. So, champ, remainder theorem says that we can find the remainder of a division. Okay. In order to find the remainder, we do the division process, right? So in order to find the remainder of a division easily through the remainder theorem. And how? It's very simple. So, champ, when a polynomial px is divided by the linear polynomial, a very important condition, divided by a linear polynomial gx, x minus a. So, champ, in that case, remainder can be found how? Simple, p of a, right? If I will put x equal to a in the polynomial px, I will get the value of remainder. Okay, champ, let me show you. Let's say, champ, we have a polynomial which is getting divided by a linear polynomial. So when the divisor is linear, we can apply the remainder theorem. So first of all, let's find the value of x, which is the 0 of the gx. How to do it? Put gx equal to 0, find the value of x, and we are getting x equal to minus 3. Right, champ? Now, we will put this x into the px. Okay? We put simple this x equal to minus 3 into px and I got my remainder. Very easy. Right? Let me show you with one more example. what is the remainder when this cubic polynomial is divided by the linear polynomial? So again, divisor is my linear polynomial. I can apply the remainder theorem. First of all, we have find the zeros of gx, right, champ? After that, simple put x equal to minus 1 by 3 into fx. That's it, right? Simply put x equal to minus 1 by 3 into fx, you will get the remainder value. Very easy. Excellent. Very good. Okay, champ. Now let's move on to the factor theorem. Okay, bache. So now, champ, factor theorem says that if a polynomial px, which has a degree greater than 1, and a is a real number, okay? So if at x equal to a, if the polynomial's value is 0, at x equal to a, if the value of the polynomial is 0, champ, then x minus a is the factor. And why so? It's very easy. After putting x equal to a in the polynomial, we are getting value 0. So this means what? This means there must be a factor of x minus a, right? Now, champ, so we can say that my polynomial is what? X minus a into some other polynomial qx, right? Very good. So now, champ, let's see this question. Show that x minus 1 is the factor of this biquadratic. How to do it? With the help of factor theorem, we can say that if x minus 1 is the factor of this, right? If x minus 1 is the factor, then x equal to 1 will be the 0 of this polynomial, right? That's it. Simply we will put x equal to 1 in this and we will check it that whether we are getting the value 0 or not. And here we can see the value of the polynomial is 0 at x equal to 1. This means x equal to 1 is the 0 and x minus 1 is the factor. Very easy. Chaliye, very good. Excellent. Okay, by factor theorem, x minus 1 is the factor of fx. It's very easy, champ. Okay, champ. So now let's see the converse of the factor theorem also. In the same way, if the px is a polynomial of degree n greater than 1, a is any real number, if x minus a is the factor, now this time, what is given? That x minus a is the factor, then p of a will be 0, right? If this is a factor, so x equal to a will be the 0 of the polynomial. So we can write again px equal to x minus a into qx. I hope it is clear. Okay, very good. So champ, let's summarize our class. Okay, what we have learned in this. So first of all, we have seen about the division algo. That any polynomial which is dividend can be written as divisor into quotient plus remainder. A very important point is what? The degree of the divisor is always greater than the degree of the remainder. So now, champ, after that we have seen about the remainder theorem, which says that if I am dividing by a linear polynomial, if my divisor is a linear polynomial x minus a, then a remainder will be what? Simple p of a, right? Excellent, very good. After that, champ, we have seen about the factor theorem. Factor theorem says that if value of p of a equal to 0 at x equal to a, the value of the polynomial is 0. In that case, x minus a is the factor of px. And the converse of this is also true, right? That if x minus a is the factor of the polynomial, then x equal to a will be the 0 of the polynomial, or we can say the value of the polynomial will be 0. That's it. I hope it is clear. Okay, champ, so that's it for this class. I hope you learned a lot and you enjoyed the class. Be healthy and be curious.